Good morning, class. I'd like to review 7B. We talked about it a little bit before the break, so I'm going to treat this as a review session. We have dependent and independent events, and this is all happening at once with similar items, okay? This one is, what's the probability of drawing 3 kings from a standard deck of cards and keeping each draw? So the first draw would be, what's the probability of getting a king on the first draw? Well, there are 4 kings out of 52 cards. And you're keeping that card. What is the probability of getting a king on the second draw? Well, you've kept 1 card, and we're talking about the probability of a king, so there's only 3 left. And there's only 51 cards left. Times, what is the probability of getting a king on the third draw? Well, we've already taken 2 cards out of the deck, so our denominator is 50, and the probability for the first was 4, for the second was 3, and this is 2, okay? Now, you should have your calculators and your dice and card chart ready, okay? And your book, because I'm going to refer to different problems if you can. So, this would be 4 times 3 times 2 on top, which would be 24. And I cannot do in my head 52 times 51 times 50. So this is a big number, okay? Then you look in the back of the book, and that's not the answer. Well, you shouldn't be concerned, because all you need to do is divide 24 by whatever this big number is, and then divide the book answer, and it should be the same decimal, okay? The second event would be independent, whereas this, you notice these denominators went down. That's because the second event is dependent on the first, and the third event is dependent on the second, is dependent on the first. Well, over here, what's the probability of having 3 boys in a family? Okay, well, that would be the probability of the first boy times the probability of the second boy times the probability, of the third boy. Well, you know, you can make a tree and get that answer pretty easily. But what if it was, multiple boys, more than 3, like 10, okay? Having the probability of having a boy is 1 in 2. You either have a boy or a girl, okay? The second boy has no bearing from the first boy, so that is still 1 in 2. Having a third boy has no bearing from the first or the second boy, and that would again be 1 in 2. Multiplying 1 times 1 times 1 is 1 over 2 times 2 times 2 is 8. And that's it for that type of example. Okay? Hold on. The next thing I'd like to talk about is the dependent overlapping events. These are 2 entirely separate events. Okay? And we talked about this. This was the probability of a club, or, remember that's the union symbol, or an ace, is equal to the probability of a club plus the probability of an ace minus the probability and the intersection symbol, an ace. Okay, I've written out the possibilities. You can see them on your card chart, okay? So, the probability of drawing a club is 13 out of a standard deck of cards of 52. That's the probability. We're not saying we did it. We're just saying that's the probability. The probability of drawing an ace from a standard deck of cards, and we are not physically drawing it, so the denominator stays the same, is 4 out of 52. Minus the probability of drawing a club that is also an ace. You obviously can say the ace of clubs. Well, there's only one ace of clubs out of 52. And I labeled these for you. Here's the ace of clubs, and here's the ace of clubs. So if I count it here, I don't want to count it twice. They've overlapped. So I have, this is my overlap. 13 plus 4 is 17, minus 1 is 16 out of 52. Your book won't have that answer. They will reduce this by 4 and give you 4 out of 13. Both answers are lovely. I don't really want a decimal because these are small numbers, but both answers are lovely, and you can just check them by dividing out your answer and the book answer and getting the same decimal. Next thing I'd like to cover is the at least once rule. The body of the problem must say the exact words at least once. And if it says that, then there's a handy dandy little formula that you can use. Sometimes it's just as easy to go through the tree, but I'm going to show you this example because we're talking about 10 days. So you obviously don't want to make a tree with 10 picks or 10 branches. It would be much too tedious and difficult. Okay, so the at least once rule is 1 minus the probability of the converse of that. Rain is 0.05, so I want to know the probability of no rain. And remember, in using that, I would say rain negated, okay? And then raise to whatever is your timeline. So that would be 10 days, or 10 years, or 10 minutes, whatever you're talking about. Okay, if the probability of rain is 0.05, what's the probability of no rain? Well, you know that rain and no rain equals 1, so you just subtract this from 1, and you get 0.95. 0.05 plus 0.95 is 1. Either it rains or it doesn't. Okay, so I take that number, the no rain number, and I go 1 minus. The probability of no rain is 0.95. The timeline is 10 days. And that gives me, I did work this one out. You enter it into your calculator exactly like this. 1 subtract 0.95 to the 10. Okay, you don't need parentheses because it's just 0.95. That's a lateral number. So that gives you 0.40. So the probability of getting rain at least once in 10 days is 0.40. Let me set up for the next problem. Okay, the next thing that I want to do is another conditional probability where we have the probability of A or B, you know, is the probability of A, plus the probability of B minus the probability of A and B. Sorry, you've got it previously in your notes. Okay, this gives me information. Well, I'm going to answer several questions about this. So I need to make my own grid. 25 French and women. 30 American women and men. Now, the W and the M can be up on the top, and the F and the A can be on the bottom, on the side. It doesn't make any difference, okay? And then you put these where they belong. And we did this together. 25 French women. Well, here's French, here's women. This is 25. 15 French men. French and men is there. The total of the French people is 40. 30 American women is 30. 20 American men is 20. That total is 50. The total is 90. 25 plus 30, I'm totaling again, is 55. 15 plus 20 is 35. And these two numbers better add up to 90, or I did something wrong, but they do. Okay, wonderful. Then I can answer a variety of questions. What is the probability of having a French person or a man? Okay, so that's the probability of French plus the probability of man minus the probability of a French man. Sorry, I'm writing on the end again. The probability of being French. Well, here's the French people. It's 40 out of the total of 90. What's the probability of being a man? 35 out of 90. Minus the probability of being a French man. French man. Okay, well, just a minute. So I'm going to cross out in red the probability of being French, the probability of being a man. Do you see that we have one overlap here? That means these 15 French men were counted twice. They were counted in the French line and they were counted in the man line. So I have to take out one set of them. 15 out of 90. So we have 40 plus 35 minus 15 is 60 over 90, or 6/9, or 2/3. Any of those answers is wonderful, and you can check them by dividing. I hope that's clear, class. That's it for 7B, folks. What I'd like you to do is try the assignment for 7B. That's our next quiz, quiz 7, which I will be uploading on Wednesday or Wednesday night, and I would expect it to be back to me by Sunday. If you have questions on 7B, you can email them to me, or you can send them to me, you can call me on my cell, okay? But the quiz will be out by Thursday. Bye-bye.